For 2 less than 100, number 1, it wants us to determine whether the matrices are inverses, and I don't know if any of you remember any of this, but when something's an inverse of something else, it means it like undoes it, you know. So in matrix land, to undo something would be to end up with this thing called these are both 4x4s, right? So there's this matrix where you have these 1s and 0s, and that's called the identity matrix. And I don't know if anyone remembers any of that, but that's kind of what we're checking for. So we want to be able to multiply A times L, and we hope that it'll give us this identity matrix. And then we even have to do the other way. We have to go L times A also, and see if we get the identity matrix. So I guess we better get cracking. So A times L. So here's how I usually multiply. I'll try to make it smaller so it'll fit. Hopefully it won't be too weird. A times L, I usually write their little names above them. Negative 2/3. Hopefully I don't write, hopefully I don't like misprint any of these and mess it all up. 1/3 and 2/3. So what you do is you have a 2x2 and you're multiplying by a 2x2. So the answer is going to be a 2x2 matrix. Now remember, we're hoping for it to be this matrix. So you multiply this spot right here is row 1, column 1. So this is my row matrix and this is my column matrix. So I'm going to multiply 2 times negative 2/3 and add it to 7 times 1/3. I think I might want to do that on scratch paper. 2 times negative 2/3 is negative 4/3, and I'm going to add that to 7/3. Does that give me a 1? I think it actually does, because we got the common denominator, and 7 minus 4 is 3. That gives me 3/3. So that actually gives me the 1 that I wanted in that spot. This is row 1, column 2 right here, this position. So I'm wanting it to be a 0. If it's not, it's not, but that's what I'm checking for. So if it's row 1, column 2, then I'm going to use row 1 and column 2. So 2 times negative 7/3, that's negative 14/3, plus 7 times 2/3. Well, 7 times 2, that's 14/3. That made 0. So that's good. Put the 0 in.
Wow,
okay.
Full house.
Yep. This is row 2, column 1. Okay, row 2, column 1. So I'm going to multiply negative 1 times negative 2/3 is just going to be 2/3. I'm going to add that to negative 2 times 1/3. Negative 2 times 1/3, that's negative 2/3. Does that equal the 0 that I want there? Yes, it does. Okay, so you guys might be able to do this faster, or maybe you think this is plenty fast. This is row 2, column 2. So I'm going to use row 2, column 2. These two multiplied together gives me 7/3. These two multiplied together gives me negative 4/3. Does that give me a 1? Yes, it does, because 7 plus negative 4 is 3, and 3/3 is 1. So this one, I'm going to say yes, that worked. Okay, but I have to do it the other way too. So this is called A times L. That's AL. Now I have to do L times A and make sure. So you have to do it twice. Are you serious? Yes, I am. Negative 2/3, negative 7/3, 1/3, and 2/3. Okay, so now this is L times A. So this is actually a very good problem because it's reminding us of all the things we've probably forgotten. We did matrix stuff earlier in the year. Okay, so L times A. Does it equal the identity matrix? I don't know. So I remember how to multiply now though. You take row, this spot right here is row 1, column 1. This is my row matrix. This is my column matrix. So row 1, column 1. So the first entry times the top entry, those multiply together to make -4/3. And then these two multiply together to make +7/3. You're adding them. Okay, -4 and +7, by now I know that that's 3. 3/3 is 1, so that's actually working for me. Okay, we can go maybe a little bit faster. This is negative, this number times, wait, what am I trying to do? Do you want to do down here or up here? Let's do up here. This happens to be row 1, column 2. So -2/3 times 7 is -14/3. And then -2 times -7/3, that's going to be +14/3. Hey, that made a 0, and that's good. Right, because it's starting to match. And then we go down here. This would be a good test question. 2 times 1/3 is 2/3. And then 2/3 times -1 is -2/3. That zeroes out. That's good because I want this to look like the, well, I don't want it to, but if it's if they're inverses, it will end up being that identity matrix. Okay, the very last one, that's row 2, column 2, so I'm going to use row 2, column 2. 1/3 times 7 is 7/3. 2/3 times -2 is -4/3, and by this time we know that that equals 3. That's just 1. Okay, so it checked. So the question was, so the answer is simply yes, they are inverses. Isn't that what it asked us? Let's see.
Yeah.